Hello everyone, let's take a look at the section 8.2 extreme points and saddle points. In these sections we're going to take a look at the technique how to find the extreme points and saddle points using partial derivatives. So to find extreme point and saddle point, the first thing you need to do is to find critical points, and then you use a test called the determinant test to classify the critical points to see if the critical point is a relative maximum, relative minimum, or a saddle point. That is, first you have to find the first partial fx and fy, and you set fx equal to 0, fy equal to 0. You solve those equations and you can find the critical point. The next step you need to do is to find second partials fxx, fxy, fyy, and fyx. Then from there you can use the determinant test to identify or to classify the critical point to see if the critical point is the relative maximum, relative minimum, or saddle point. To test or identify the critical point, as I mentioned, you're going to use the determinant test. It's right here. But you don't have to memorize all of this information. This information will be provided to you in the test, so you don't have to memorize this. But you need to know how to apply this test in order to identify critical points. Now let's take a look at an example. Consider the function f of xy equal to 3x squared minus x cubed plus 12y squared minus 8y cubed plus 10. As I mentioned, in order to find extreme point or saddle point, the first thing you need to do is to find critical points. In order to find critical point, you have to find the first partial. So fx equal to 6x minus 3x squared. This is the partial derivative of f with respect to x, so you treat y as the constant. That's why you have fx equal to 6x minus 3x squared. Similarly, for partial derivative of f with respect to y, x is the constant, you have fy equal to 24y minus 24y squared. Now you set fx equal to 0 and fy equal to 0. You're going to solve the equations. This is 6x minus 3x squared equal to 0 and 24y minus 24y squared equal to 0. And you can do this algebraically, or you can use the solver in the calculator. But when you use the solver in the calculator, you have to be careful because this is the quadratic equations that can give you two solutions. So you need to guess two different values. In order to get x equal to 0, you can try, or you can guess x equal to -1, and then you hit solve. They will give you x equal to 0. Now if you want to get x equal to 2, you can try, or you can guess x equal to 1, and then you hit solve. It will give you x equal to 2. And you can apply the same method for the equation 24y minus 24y squared equal to 0. The solution is y equal to 0 and y equal to 1. Here you can mix and match the coordinate of x and the coordinate of y together to get the critical point. And therefore the critical points are 0, 0. So this is the combination of x equal to 0 and y equal to 0. The next critical point is 0, 1. This is the combination of x equal to 0 and y equal to 1. The next combination for critical point is x equal to 2 and y equal to 0. And the last point is x equal to 2 and y equal to 1. Next, we're going to find the second partials because we're going to classify the critical point we just found earlier. To find second partial, you need the first partial. So from fx, you have 6x minus 3x squared. fxx is equal to 6 minus 6x. And fxy is that you're going to take the function 6x minus 3x squared, and you're going to find the partial derivative of this function with respect to y. But there's no y in this function, therefore fxy is equal to 0. Similarly, fy equal to 24y minus 24y squared. fyy is 24 minus 48y. and fyx of course equal to 0 because you take this function and you find the partial derivative with respect to x, but there's no x in this function, so therefore fyx equal to 0. Now you use the determinant formula. This is equal to fxx times fyy minus fxy squared. That is 6 minus 6x multiplied with 24 minus 48y, and then minus 0 square, but I'm not going to write minus 0 square. So this is the determinant, and we're going to use this determinant to help identify or to help classify the critical points that we found earlier. In addition to that, sometimes we need fxx, so we're going to include fxx in this discussion. Now let's take a look in more detail about each critical point and how the determinant and fxx help identify or classify the critical point. Now let's take a look at the first point, 0, 0. So the determinant is that of 6 minus 6 times 0 times 24 minus 48 times 0. If you use the calculator, you will get this 144, which is positive. Now if you go back to the first few slides, you see the determinant test, and it says that when the determinant is positive, there are two possibilities. The first possibility is that when fxx is positive, the critical point is the relative minimum, and when fxx is less than 0, the critical point is the relative maximum. So let's take a look at fxx. So fxx you have right here is 6 minus 6x, so at the point 0, 0, you get 6 minus 6 times 0, which is equal to 6. This is positive. So for the first point 0, 0, the determinant is positive. fxx is also positive. So this critical point is a relative minimum. Next, for the point 0, 1. Once again, you substitute x equal to 0 and y equal to 1 into the determinant. And you have 6 minus 6 times 0 times 24 minus 48 times 1. And once again, if you use the calculator, you can get the determinant to be negative 144, which is less than 0. And you go back to the determinant test, you see that, when d is less than 0, you can automatically jump to the conclusion that the critical point is the center point. For the third point, 2, 0, you do the same thing. You apply the determinant formula, and you let x equal to 2 and y equal to 0. So you get 6 minus 6 times 2 times 24 minus 48 times 0. And if you get the calculator, you can get this as negative 144 again, which is a negative number. And once again, you can jump to the conclusion. When d is less than 0, the point is a saddle point. For the last point, 2, 1, the determinant is 6 minus 6 times 2 times 20 minus 48 times 1. This is equal to 144, which is a positive number. So here d is positive. That means you have to find the side of fxx. So that is 6 minus 6 times 2. This is minus 6 less than 0. So as I mentioned earlier, when d is positive and fxx is negative, the critical point is the relative maximum. And this is the end of sections 8.2. Please let me know if you have any question.